The first time I shipped what I would now call an AI agent graph, I did it by accident. I had one loop researching, writing, and judging its own output. It looked efficient until it calmly approved a script with a broken claim, because the same context that invented the sentence also graded it. The verifier was not independent, it was tired. My fix was not a smarter prompt. I split the work, kept one shared whiteboard, and made handoffs explicit. The quality jumped because the system stopped asking one brain to be the worker, manager, and auditor. A single reliable loop is powerful. It can plan, act, check, and stop. But it hits a ceiling when one context has to carry too many jobs. Research wants breadth. Writing wants selection. Verification wants suspicion. Those are different mental postures, and stuffing them into one prompt often creates mush. The loop may remember the wrong details, optimize for the last instruction, or rationalize its own mistakes. You also lose operational control. If the research step fails, do you retry the whole job? If rendering fails, do you regenerate the script? Naive agent systems answer that with more prompt text. Production systems answer it with structure. The pattern is simple. An agent graph is nodes, edges, and shared state. A node is an agent loop, not a prompt blob, not a personality, a loop with its own goal, tools, verifier, budget, and stop condition. An edge is a handoff rule. It says when work may move from one node to another and what condition must be true first. Shared state is the one whiteboard every node reads and writes. Your normal loop is already a graph, one node pointing back in itself until done. A multi-node graph does not replace loop discipline. It governs multiple loops so they do not step on each other. Mechanically, build the graph from the outside in. First, define shared state, task, artifacts, decisions, errors, budgets, and verifier nodes. Second, define nodes as loops. Each node gets an input slice from state, performs bounded work, verifies its own output, then writes a small update back. Third, define edges. An edge is not vibes. It is a rule like fetch to script when source is saved is true, or render to repair when render error exists. Fourth, define terminal states, uploaded, rejected, needs human, or budget exhausted. Notice the opinionated part. I prefer nodes to write artifacts and facts, not hidden intentions. State should be inspectable when the system wakes you up at midnight. My daily content pipeline is easy to draw as a graph. Fetch, script, render, verify, upload. Fetch is a loop. It gathers source notes, checks that required fields exist, and stops only when the state contains usable inputs. Script is another loop. It drafts, checks length and coverage, revises, then stores the script as an artifact. Render is a tool-heavy loop with retries and hard timeouts. Verify watches the final asset, not the promise. It checks audio, title, description roles, and missing files. Upload is deliberately boring. If verification passed, publish. If not, stop. The graph does not make any node brilliant. Graphs add control, but they also add new ways to fail. Shared state can become a junk drawer if every node writes long, unstructured essays. Edges can deadlock when no condition becomes true, or loop forever when two nodes keep bouncing the same artifact. Nodes can overtalk. One node rewrites another node's decision instead of producing its assigned output, and costs can rise because you now have several loops, several verifiers, and more orchestration. The fix is not to avoid graphs. The fix is to keep them boring. Type state fields, explicit ownership, max transitions, per node budgets, and a terminal fallback that says, stop, and ask a human. This sits in the graphs tier because we are moving from one reliable loop to coordinated loops. Everything from earlier still matters. Stop conditions, budgets, tool boundaries, verification, logging, and recovery. The graph just gives those disciplines a larger shape. Shared state becomes a contract between loops. Edges become policy. Nodes become replaceable workers with clear input and output. Later, when you run fleets, this is what lets you swap a model, retry a failed renderer, or quarantine a bad verifier without rewriting the whole system. The big framing is worth repeating. Graphs govern loops. They do not excuse sloppy loops. Try this today in 10 minutes. Pick one automation you already run, even a small one. Draw it as a one-node graph pointing at itself. Plan, act, verify, stop. Now circle every mixed role inside that node. Is it collecting data and judging truth? Writing code and approving tests? Drafting email and deciding compliance? Split exactly one role into a second node. Do not rebuild the system. Just define the shared state fields, the new node's verifier, and one edge rule that allows handoff. If you cannot write the edge condition clearly, that is the lesson. The handoff was probably vague in your loop too. 3 beats to keep. First, a single loop is already a graph. One node pointing at itself until a stop condition fires. Second, in a real agent graph, nodes are full loops with their own verification, budgets, and stop rules. Third, the graph adds governance, handoff rules, shared state, ownership, and terminal outcomes. It is not magic, and it will not save a lazy node. But it will keep research, writing, rendering, and verification from collapsing into one confused context. This is loop engineering, building agent systems that finish, verify, and stop. New loop engineering episode daily on this channel.